Hi, everyone. My name is Mike Bomba, and I'm going to be leading today's discussion on load balancing in the U.S. federal government. For the last 5 years, I have worked as a Kemp Senior Solutions Architect with a primary focus on the U.S. federal business space. Before Kemp, I did 35 years in Department of Defense, primarily as an engineer, both as a officer and as a civil servant. During that time, I engineered, my team engineered, designed, fielded what is now the Army's global portion of the DoD Global Information Grid. So we were responsible for everything from defining the standards to working with companies to achieve our objectives to design and field this overall network. I've got experience both in the engineering and in the support to operations after engineering. I'd like to thank you all for spending time with us today. And I want to spend a little bit of time on load balancing and talk about it before I talk about the actual use of it in the federal government space. Load balancing is a key technology that allows you to deliver an exceptional application experience, otherwise known as AX, to your customers and employees. Application experience is a relatively new term to describe something that we all have to do. You know, we put in networks, we put in data centers, applications, firewalls, operation centers, and everything to do one thing, and that's deliver information to those people that we need to, whether they're our employees or they're our customers. In the federal space, we still have customers. I mean, you have to do your online taxes as an example. The IRS is the provider. We are all a customer of the IRS. The important thing about application experience is we're now trying to put together all the pieces that say that what do you need in order to guarantee the user has a really good experience with the applications you put in the network, and how do you make sure you are protected from rogue users in the network. We're going to talk about how to break your dependence today on complex and expensive technology. A lot of you, load balancing, you've been doing it for a while with some of our competitors. Your experience with them probably is this stuff is expensive and it's hard. With Kemp, it doesn't need to be expensive and it doesn't need to be hard. And we're going to talk to you about the differences in the current generation of technologies versus the legacy products that are out there today. And at the end, we're going to spend a little time talking about what some of the federal agencies that work with us have been able to achieve as far as real savings using our technology. So this is at a high level the areas we're going to talk about. Brand reputation versus vendor lock-in. We're really going to be talking about the challenges that you would have if you decide to pure fleet your environment to a single technology. The use of operational requirements and solicitations versus technical requirements. The government had a big push when I was still in the government, trying to get people to quit writing only tech specs and contracting language. And what they were trying to do was allow for alternative solutions that may cost less or may actually provide a higher value in the actual solution. If all we do is put tech specs into a solicitation, all we get is what we ask for. And we ask for what we know. And if all we ever get is what we know, we will never know anything else. We will never learn and grow as organizations or as individuals. Ease of use is a challenge for a lot of ADC vendors. With Kemp, not so much. We've designed our product from the very beginning to be easy to use. We've kept that design philosophy in our product over 15 years. And we are undoubtedly the easiest to use product in the marketplace that meets all federal standards from a security perspective. There's a chance that when you bring new technology in, the vendors that you currently have will try to convince you it's too hard to do. Load balancing is a mature technology. It's been out there for a long, long time. It sits between the user and the application server. It acts as a proxy server. You can put many proxy servers in the network. You can add them and remove them anytime you want to. You can add and remove load balancers to your network anytime that you want to. You can switch applications on and off by a simple change in DNS and domain name service. which means you can do this with almost no to no impact on your user base. So saying it's hard to make a change is only a tactic your current manufacturers have to try to keep you with them instead of let you experience easier and less expensive solutions. And then last, total cost of ownership. When doing solicitations, if you do them and you're only looking at the cost for the current year, the acquisition year, a lot of tactics that vendors use today is they will go ahead and bid low and then try to fix it on the out years, on the sustainment years. That technology, that strategy doesn't work if your solicitation requires they provide a 5 or 8 year TCO estimate or include 5 or 8 years of support as priced options on the contract. When you do that, you take out the risk that a company is going to try to buy in low and then get well on the support and sustainment side. So here's like a mission statement. How can you? And we're going to help you understand how you can. How can you deliver an excellent application experience? How can you do that while reducing cost and complexity and improving security? How can you do it in an environment where you don't have ready access to your physical data center? So you may have to expand into the cloud and use strategies like hybrid cloud, where you have some compute on-prem and some compute in a cloud provider, or maybe across multiple cloud providers. We'll talk to you about how load balancing is critical to enabling those workloads, and then how using Kemp can make it easy and affordable for you to do so. So what are load balancers? You know, and so their application, we've talked about it a little bit. What does the industry experts, not Kemp, think about this technology? We have a couple of data points here from Forrester and from ZK Research. Gartner, we've had them in as well. The bottom line is most organizations know what a load balancer is. They know it is fundamental to maintaining the best application experience for their customer base. They know it is fundamental to securing the infrastructure the applications run on. The companies that this study was done were large companies, and they say, you know, between 50 to 400 applications on a given load balancer is what they're used to seeing. They're used to seeing that because the load balancers for these companies in the past would cost hundreds of thousands of dollars, and they had to find a way to stretch that across those platforms. Kemp is primarily a software company, so our product, while it's sold in hardware and sold in cloud appliances and sold in virtual appliances, is primarily driven by a philosophy similar to Microsoft versus a philosophy similar to the old Sun Microsystems, where it was their OS, their hardware, all of the R&D that goes along with that. So Kemp, our intent is to drive down cost, drive up simplicity, and let you use load balancing where you need to use it, not simply where you can afford to use it. Enterprises are moving to multi-cloud, and I think this is accelerating quite a bit right now. I don't have the research back on this yet, but what we're hearing anecdotally is that more folks are going into the cloud right now than have in the past year, primarily because they can stand up capacity without having to go into their physical data center and add additional servers and storage. So it makes it faster for them to deal with it. And in some cases where things are shut down tightly, getting into these data centers isn't as simple now as it was 6 months ago. So what is application delivery? What are application load balancers? What do they do? This slide's got a set of features and functions listed on it. It's all about enabling availability for the application. So if an application instance, if one server fails, then there's actually, when you design a high availability environment, you put in more than one server, more than one copy of an application, often more than one data center. But if you don't know the application is behaving badly, the way that the system would operate without a load balancer is DNS would simply give out an IP address. The user would be the one that connects to a server not behaving properly or an application not behaving properly. The user would find out, they would call up your service desk. Your service desk would have to go figure out if it's a unique user problem or not. Once they finally figured it out, they would take that server out of rotation manually. In the meantime, all the rest of the users coming in, hitting that server, get a bad experience. You don't want bad experiences. I mean, right now, you know, the world is dependent upon its infrastructure, this network infrastructure and application infrastructure that's reachable from at home as well as the business. And you need to ensure that these applications are highly available. To do that, application load balancers actually health check the applications. They know the application's up and running. They don't give out an IP address, or they don't allow a user to connect to an instance that's behaving badly. So this keeps users connected to the ones that are working well. It notifies you when ones aren't working well, so you can take action and begin to fix it. Scalability is another issue. You know, what your applications may have been designed to deal with 500 users concurrent. All of a sudden, there are 50,000 users. How do you grow quickly? Well, an application load balancer sits between the users and the application servers. You can make the pool bigger or smaller, more servers, more locations. The users never see it. They just become available to the users as the resources come online. So you can elegantly scale out capacity by simply adding resources to the back end of these load balancers, and then the users can consume those resources. From a security perspective, the application servers, if you let a user directly connect to an application server, it's only a matter of time before that server is compromised. And it's not a real long period of time, because there's lots of attacks that are operating system related, that are actually network related, that can be successful against servers even today. If you put a load balancer in, it acts as a reverse proxy, and the only thing the user can do is talk to the load balancer and then ask the load balancer for information that it passes to the server. There's still a chance for an inbound attack, and that's why there are things called web application firewalls, which we include and all the other major vendors do, to ensure that a user is behaving properly when they're talking to the application server through the load balancer. And then control. By having a load balancer in the past, you can enable things like single sign-on. You can go ahead and control exactly which folders, directories within a website users are allowed to access. If you have a dev site on the web server, you can specifically exclude that from access, and people can't get to it no matter how hard they try. It's a gate between the user and the actual infrastructure. So why, right? Why should this be really important to you now or at any time? And the real bottom line here, and I think you may have seen it yourselves going out on the network, is when things work poorly, you get frustrated. And if you get too frustrated, you simply leave. And if you are responsible for delivering services to customers, and the customer's experience is negative, they will not be able to receive the service that you're supposed to deliver. If you can't deliver the service, then you really aren't relevant, and the whole thing becomes to fall apart. Why should you be funded if you can't deliver the services that you're supposed to be delivering? Why should the existing staff stay in place if they can't meet their mission requirements? Why, are you there at all? Why not find somebody else to do it? So it is important that applications perform as expected by the end users. That doesn't mean it needs to be as fast as lightning. That'd be nice. It was worked at the speed of bits and on the network. But it needs to be responsive. And the way that you can assure it's responsive is putting in application load balancers that check those applications, know what their response speeds are, notify your network centers when something isn't responding well, connect users to the best performing instances of the application. People are getting really tired about the next data breach. I mean, it's every time you turn around, it's another one. You get a notice that hey, there's another free offer for credit protection service because I lost all your sensitive data. You simply, these things can kill companies. There was a company a little while back that was doing background investigations for the U.S. government. They had a major data breach. The company went under. They could never recover from it. You do need to understand that your reputation is really, really important in this space. And if people can't trust you to protect their data, then they will not use you, and you will not be able to survive in this world. And that's the whole business of reputation. It's hard to have a good reputation. It's easy to damage your reputation, and getting it back takes a long time. It's like trust in a relationship. Once you've lost it, getting it back takes a huge amount of work. Relevance. If you aren't doing what you're supposed to be doing, then why are you there? Bottom line. And if you can't access the applications that you present to them to do what you're supposed to do, why are you there? And then the ripple effect of bad investments. And this is a relative term. What I really meant to say here is investments that increase your out-year costs or your manpower costs or your training burden, or the amount of money you need to do a tech refresh to go ahead and update the technology. Investments that drive personnel increases in training or complexity, or dollar increases for sustainment, they can be seen as bad, meaning that in a world where budgets can get constrained quickly, you could be put in a position where you can't afford what you got. What are good investments? Good investments are ones where you can go in, and today especially, where you can go in and you can achieve an objective. You can give the service you need to the customers that are out there securely. You can reduce your cost of delivering that service, and especially right now where you may have, if you're a commercial entity, you may see reductions in revenue streams coming in, and the last thing you want to do is increase your costs going out. So you can go ahead and have an opportunity to not only not increase your costs, but perhaps even recover money in your budget. You can keep your reputation intact, and you can have happy customers. So load balancing, both cloud and multi-cloud, global load balancing and application load balancing, these are all terms you may have heard. Real quick rundown on the different computing architectures. On-prem is on-prem. It can be virtual or physical. Cloud simply means you have something running in Azure or AWS or a similar cloud service provider that is delivering services to a customer. Multi-cloud is where you've decided that the application you're delivering is important enough that you want to isolate yourself and you want to protect yourself from the possibility of a single cloud service provider failure. So you can go into multiple zones in the same cloud service provider, or you can go ahead and say, I want to completely isolate myself. I'm going to have instances in Azure and in AWS at the same time. That's a standard multi-cloud, where if Azure fails, AWS does continue to operate. And failures in these networks isn't typically anymore the old fiber cut, lose a data center business. They're human related. People make a mistake in configuration management. That mistake gets replicated around the data center, and before you know it, the whole data center is behaving badly. And if you have application load balancers watching how applications perform, you know when that happens. The data center may still be physically running, applications are behaving badly, so you now are directing people to where the applications behave the best. And then hybrid cloud is where we're talking both a combination of on-prem and cloud computing. It can be on-prem and multi-cloud, or it can be on-prem and single cloud, but it's a combination of physical hosting, virtual hosting, and cloud hosting. Again, to ensure that you can use all of those resources, you need to have something that connects the users to the applications as the user requests come in, no matter where the application is hosted. So a little bit of detail slide on application load balancing. This is a Kemps oriented slide, but honestly, the same technologies are available in most of our competitors. The intent here is to show that when a user, typical network designs have external access zones called demilitarized zones, internal access zones for people that are inside your network already. If you do a lot of VPN for remote users, they look like they're inside your network. And to intermediate the user to the server communications, you need load balancing. And load balancing typically will sit both in the demilitarized zones and in the server enclaves. Different mission sets. The DMZs are where the external users come in. And you'll have physically separated or logically separated hardware in there to make sure that they can't get beyond an edge experience with your data. You'll have inside the network experience with your data to include the developers and everybody else that is inside that data center enclave. So the feature sets listed, you can see it, you've probably read it by now. Global load balancing, layer 4 and layer 7. Layer 4 means application load balancing. I'm sorry, layer 7 means application load balancing. Layer 4 is network load balancing. Most of the time you're going to do application load balancing. That's what these devices are built for. But you can load balance network level protocols as well. So if you had an OCSP cluster, online certificate status protocol cluster, and you needed to load balance across all the nodes, you can use the same technology to do that with that you're using to load balance IIS or Apache Tomcat or anything else you have in your data center. SSL offload is taking the encryption traffic off of the server and putting it on the load balancer, and that offloads the server so the server has more resources in order to satisfy requests. It's a common strategy, and it's used also whenever you need to inspect the content before it gets to the server. So the load balancers can offload that content. They can then inspect that content, web application firewall, and then they can send that content to the back-end server, and they don't have to re-encrypt it, or they can, depending upon your security requirements. If you don't re-encrypt it, then the servers aren't doing the encryption, which is processor intensive on the server side. On our side, we use specialized ASICs to do it with in most cases. So improving the user's experience, improving the speed the servers can actually respond. These devices are reverse proxies. They cache and compress. They're in the network. So the user's experience and the server's experience, load on the servers, are all improved by using the technology. In addition to application load balancing, global load balancing deals with the multi-data center scenario. So you decided that you wanted to scale out by putting something in Azure and AWS. You still have something on-prem where you have multiple data centers yourself you operate. How do you get users connected to where they get the best experience? DNS doesn't care. It'll just send them whatever's next in the list on the DNS server. The way that global load balancers work is they use the DNS protocol, but they're intelligent devices. They have the ability to health check the things you're providing IP addresses on. They don't give out IP addresses for things that aren't working properly. They have the ability to schedule in ways other than round robin, like you can do proximity and location-based scheduling. You can do weighted round robin scheduling. You can do least connection-based scheduling. You can do resource-based scheduling, where you send the user the next connection request to the data center that has the most resources available to satisfy that user as best as possible. So global load balancing on top of application load balancing is how you deal with multiple data centers, multiple application instances. And in some cases, in any one specific application, the application may say, from their reference architecture for the application, a good example is Link or Skype for Business. They will tell you, if you have an on-prem instance, these specific pieces of your architecture should be DNS load balanced, and the rest of it should be application load balanced. Well, DNS load balancing, again, it benefits from the health checks, so you know the component is actually up and running, so you can use global load balancing even inside a single data center for certain applications that require a combination of DNS and application load balancing. Kemp's commitment to federal. We're all in. I came to the company, I'll say 5 years ago. I came out of an area where I did a lot of information assurance engineering. I mean, I was involved in all the security technical implementation guidelines that were developed in the SRGs, security recommendations and guides. I knew exactly what the federal government required from a security perspective because in a lot of cases I was a reviewer of the documents as they were being built. So when I went to Kemp, I laid out exactly what we needed to do. They did exactly what I asked them to do. I took the product myself through JITC testing. We have a perfect IA scorecard, and you can't get better than perfect. There's nothing in our information assurance, our security testing, that requires fixing, which is wonderful. So and in addition to that, we've undergone the U.S. government testing for FIPS 140-2 for cryptography. So the U.S. government has a policy that says you don't use cryptography that hasn't been validated through testing to work properly. And that process is this thing called FIPS, Federal Information Processing Standard number 140-2. And the process, and when you're completed, once you go through the labs and they get tested, they put you on a website, and then you can show that you've actually completed testing successfully. And Kemp is there. Kemp actually does this at the operating system level. We embed cryptography into the OS. We build it in. Our competitors have a long history of bolting it on. They'll find a card, they'll stick it in their chassis, they'll go ahead and test the overall system. But we believe that security should be available for everybody. Even products we give away have the same exact security in them. So JITC certified, Joint Interoperability Test Command. If you heard DoDN APL or UC APL, they're the same thing now. We're on the approved products list. So who are the key players in our space? Who do we see all the time? And what's a little bit different about us and them? So in the area of who's approved for use in DoD, the ones that are approved are actually these multi-platform support companies. So Kemp, F5, Citrix A10, they have listings on the DoDN APL. They have listings in the FIPS 140-2 website that they're running validated cryptography. The other competitors we run into from time to time are the single point solutions in the cloud, AWS and Azure. They have a load balancer. VMware has now added Avi. They have a load balancer. It's embedded in their platform. They don't have the ability to use that load balancer in other platforms. So if you're in AWS and you also have on-prem, you can't use the AWS load balancer on-prem. It doesn't work. They don't have an appliance version of it. It does not exist. If you're going to have an environment where you live in more than one computing environment, then you need to have platform-based load balancing. Sometimes they call it hardware, sometimes they call it external. It is a product that actually is designed to work in multiple computing architectures and lets you use all the capacity no matter what computing architecture you're using. So Kemp started this business with easy-to-use products. We built ease of use in, ease of use. I can't say it enough because it is core to our philosophy as a company. Make everything as easy as we can, but not make it simple on the back end. So the back end of these systems are very complex. I mean, they support things like CAC certificate to Kerberos translation for replacing things like the old Microsoft Threat Management Gateway. So they're not simple systems, but we provided, through a lot of hard work on our part, simple user interfaces to access these systems. And we provided templates that automate the configuration of certain workloads. Some workloads, if you don't have templates, it could take you a day or two to get set up and configured and tested and working properly. What a template is, it's a script that's actually read by our appliance that automates the creation of a virtual service and all the associated rules and all the associated health checks. For example, for Exchange 2016 or 2019, if you run the template, it'll create 9 sub-virtual services, 9 separate individual health checks, about a dozen rules, integrated all together inside of a single virtual service, and all you have to do, all an operator has to do, is type in IP addresses and maybe load a certificate, and it's up and running. It takes about 15 minutes total time, including typing in the IP addresses and loading the certificate to configure for Exchange 2016 or 2019 or 2013 or 2011. 2010. All of those are simple workloads for us, because we built the automation scripts, and these scripts are built, they're called templates, are built in accordance with the manufacturer's best business practices, not ours. So we use a reference architecture for Microsoft when we build the Microsoft scripts. Same thing with VMware for Horizon Workspace and the Horizon View. So making things simple is what we do. And another thing you can look at if you want to is, especially in commercial companies, you can easily see the amount of revenue that's generated by services versus product. When you get to see companies where services revenues are massively outstripping product revenues, or even over 50% product revenues, you know that company is building a product that they're designing to be complicated so they can drive additional service revenue. It's the only reason. I mean, if it wasn't complicated, you wouldn't need to sell all those services. And so Kemp is designing our product to be easy to operate. Our service revenues is maybe 15, 20% outside of support renewals of the company. Our competitors, much worse than that. And I'm not going to give you specifics because figures lie and liars figure, and I'm not going to throw numbers out I don't know for certain. But I can tell you, because I've worked with all these companies when I was in the government as well, hard drives manpower and hard drives additional services, and Kemp is not. Kemp is designed for easy use. So what are common misconceptions? It kind of goes back to the same thing. You know, is it complex? Behind the scenes, yes. To the user, it doesn't have to be. So if you're used to, if your entire life's experience has been, this is hard and it's painful, if that's all you ever know is load balancing is hard and painful, it's all you've ever heard, all you've ever seen, then when we tell you it's not hard and it's not painful, you're going to go, but it's always hard and painful. It's all I've ever known. The answer is you've picked the wrong partner. You need to find somebody who helps you understand that it doesn't need to be either of those two. It doesn't need to be expensive. If you go with a vendor who is primarily hardware focused and has a massive manpower burden and has a massive R&D burden for hardware design and development, their products are going to be expensive. With companies who are designed primarily around a software model, like Kemp is, you're going to find that the products are not going to be expensive. I mean, we could jack our price up to match or come close to our competitors because our feature set's very similar, but we choose not to. We want to be disruptive in this marketplace. We want you to like us, and we work very, very, very hard so that you like us. We run a 98% post-sales customer satisfaction rating. Find somebody else in the industry that can prove to you that they have a 98% post-sales customer sat rating, and I'd be surprised. I haven't seen anybody. And then change is not difficult. I mean, change is necessary. It's relevant. It's important. You have to do it. And if these devices can sit side by side and then switch over is simply one change of one database called DNS, 5 minutes worth of work, and all of a sudden you're going on the new system versus the old system, it's not difficult. People tell you it is, it's really not. So these things, there's going to be a banner that pops up afterwards, but what's important here is these are kind of words that when you see them, you need to take pause. There is no reason that you should pick proprietary standards. There's no reason that you should go ahead and say, and have to future-proof your investments, because your investments are going to change over a 5 or 7 or 8 year period. You're going to buy new technology, refresh the environment. You know what your requirements are now. If somebody tries to sell you a product that's got 100 extra features that you don't use today, and you have no plan to use tomorrow, and they're telling you you need this to future-proof your environment, what they're really saying is you need to pay our price, and the only way I can do that, convince you to pay our price, is by trying to sell you things you're not going to use. Selling things you don't use is not a business strategy Kemp is involved in. We size with our customers. We work very closely with them to make sure that they get the technology they need at the size they need with the features they need to meet their mission requirements. And that includes any known or planned upgrades into the future. I can't tell you how many places I've gone where I've seen an F5 running basic load balancing. If you have an F5 with an LTM with a basic license, and they're telling you you can't use somebody else because of all the features in our product, those features aren't in the basic license. You're using a basic load balancer, and you're spending a boatload of money to do it, and you're driving your manpower costs up. So vendor lock-in, this is important because I don't want you only in Kemp either. The important thing is you need to have a diverse ecosystem. You need to have at least 2 vendors, 2 manufacturers for any technology you use in your infrastructure. You need to be able to use them best where they fit inside your infrastructure. So you find products that like Kemp, which are very easy to use. If you have places, a lot of the deployed forces in the Department of Defense use us. They use us because they can't get people trained on F5 and trained on a weapon at the same time, and they rotate people in and out really quickly. They just simply can't do it. They have to have technology they can use, a junior network tech level user interface to meet their mission requirements. So we've gone throughout Southwest Asia. They basically fight the war on all the networks using our technology. So when you find, where you find opportunities where in your environment, the ease of use is really important. Training is a burden, right? Or cost is really important. You can go and return some money. If you're using expensive technology to do simple workloads or even moderately complex workloads, why are you doing that? Why are you if you're doing it because you think you're saving money because you don't need to retrain somebody to use a second technology, if the second technology is a lot easier than the first one is, you don't retrain people. The same person can handle the second set of technology. It's like telling a transoceanic airplane pilot that you have to be retrained in order to fly a leg between New York and San Francisco. It doesn't make any sense. These people if you have people who are trained to do the most complex workloads out there, they can easily pick up simple workloads like Kemp. So what do you want to do to keep vendor lock-in from happening? To stay away from this pure fleet strategy. One, of course, is operational requirements. One is don't cut technical specs and stick them in a solicitation. Please don't do that. When you do that, again, you're telling the world, I know all I'm ever going to need to know, and this is exactly what I want, and I don't want to hear nothing else from you except what I want, because I know what it is, and nothing you can tell me will change my mind, and I don't need to learn anymore, because I know all I will ever have to know. And it's arrogance, right? You don't know, nobody knows all they will ever know or all they ever need to know. So we're always learning as human beings and trying to improve. Stay away from proprietary standards. If you see a solicitation where somebody's running a solicitation, if you're involved in contracting and somebody says, hey, I want to do a sole source, I want to do a brand name justification, and I want to cite proprietary standards as the reason for it. The first thing you should ask is, why are we using proprietary standards in our network? Why have we hog-tied ourselves to a single manufacturer? What is the reason we've done this? Can we untie this? Can we fix this so we can more elegantly compete and keep our costs down and our change opportunities, our ability to improve as an organization high? And then that's pretty much it. What happens when you have complex systems? Of course, it takes longer to deploy, it takes longer to train, it takes more complicated and expensive manpower, it takes more money to buy. So you want to be able to be in a space where you can buy the technology that meets your mission requirements and doesn't drive your costs to the roof. So we talked about operational requirements a little bit already. This is defining what you want to do, not how you want to do it. A good example is I need load balancing to cover 4 data centers with 50,000 users of Microsoft Exchange, well, maybe not today Exchange, but you could say SharePoint or IIS or Apache Tomcat. And let the vendors come in and ask you questions, and they will say, well, tell me a little bit more about the application, how many concurrent users. Give them some data about the application, then they will tell you what they think the best answer is to meet your requirement. And you'll get bids from all the different vendors, and you'll see all the different technology solutions in those bids. And you can then see if you use total life cycle costing as a criteria in the solicitation, you can now see what complex solutions drive you to as far as cost goes. And you can make a decision, which do I want to do? And in most cases, I hope that you're going to pick a decision that this is the one that's in the best interest of my company. It's going to save us money, it's going to save us manpower, it's going to meet the mission requirements. There are going to be cases where the competitors out there who they may have a feature that nobody else has, and you may have to have that feature, and that's fine. But because there's one feature that you have to have, doesn't mean that everything you buy should be from that company. You buy that feature for that product at the place you need it in your network, and then you keep putting in affordable and easy-to-use technology everywhere else. It'd be like saying, I've got a need to transport 500 people from Chicago to Detroit, and one of them has to get there fast. So therefore, I'm going to go and buy 500 Ferraris or 250 two-people cars because one person has to get there fast. It doesn't make any sense, right? That's a nonsensical argument, and yet that's the same argument that these manufacturers will have with you, trying to convince you that because we do one thing nobody else does, you need to use us everywhere. That's not true. The easy use is really important. I was going to write this slide originally with just that does not need to be hard and expensive and list it like all the way down the slide because it does not need to be hard and expensive. we're the proof of that. If you don't believe us, bring us in as an evaluation, put your hands on us and see it yourself. But our design is a junior network technician level skill set to operate the technology. Change is really, really important. If you don't change, you don't grow. If you don't grow, you typically die. And the key here is that you don't know what you don't know unless you allow people to come in and offer you opportunities to change. You can't get any better than you are today. I like these two quotes, Yogi Berra, if you keep doing what you're doing, you're going to keep getting what you're getting. And then Einstein is absolutely spot on. Repeating the same experiment and expecting a different result is the textbook definition of insanity. So if allow change in your network, and then you can stay relevant. Okay, why is single sourcing bad? We've talked about this already. So companies get bought and sold all the time. What I didn't tell you was you can have a supply chain issue that kills a product. It could be that the source code is stolen. It could be the company is bought by somebody that's an adversary. It could be that the company itself goes belly up. It doesn't make a difference how big the companies are. Big companies get bought. I mean, look at EMC being bought by Dell. It's a huge company being bought by somebody else. If something happens to your primary supplier, you need to have a secondary supplier, a different manufacturer already in your inventory running today so you know exactly how to use it, and we think that ought to be us. If we're not your primary, with somebody else being your secondary, we should be your secondary. But you should have in your inventory easy-to-use technology designed for affordability, in addition to whatever else you have. And then we talked about this already. Yes, you can have different manufacturers in the network at the same time, especially with technologies as mature as load balancing. There is no science, there is nothing secret about load balancing between different manufacturers. We all health check, we all schedule, we all distribute traffic across multiple backend servers. We all use DNS for global load balancing with health checking and advanced scheduling mechanisms. A web application firewall technology that's available to protect the application servers. And we all act as a reverse proxy. At the most basic level, we sit between the user and the application server. So if they all operate the same, then you can bring technology in and take technology out easily. And then this is just an example. Our customers, the Air Force, and I can't give you the specifics, and I don't want to because of national security issues, but we've saved the U.S. government and just these major customers over $20 million. And it wasn't hard to do. It was very simple to do. And the cost savings analysis I do is real basic. It's what is the cost of the product and support. I'm not adding any of the training burden. I'm not adding any of the manpower burden, differences between the two technology sets. I'm not adding the delays, costs to complexity for fielding. None of that is in these calculations for TCO. It is strictly the acquisition cost and the sustainment cost over a period of time. And then we're getting close to the end, so and if you haven't had a chance to put questions into the chat line, please go ahead and do that, so I'll be able to answer your questions as we get close to it. But these are some of my lifetime lessons learned, and the number one, and the one that used to aggravate me the most when I was in the government, was somebody telling me that what they built should be my requirement. Requirements are generated by business needs, not by technology vendors. Solutions come from the technology vendors, not requirements. If a manufacturer ever acts so arrogant, they tell you that they should be, what they build should be your requirements. We own this part of the network segment. We are dominant. We're the only key player. Any of that stuff, arrogance kills, and the fact is they are your requirements. You need to own them. Easy is always better than difficult. It's a common, you think, well, this makes a lot of sense, right? But when you buy stuff, sometimes you forget who you're going to turn it over to operate. And if the operator can't operate it easily, what happens is you have delays in fielding and expenses and training that you weren't planning on, or additional manpower requirements. Easy is better than complex across a lot of aspects. Affordable does not mean incapable. If we design a product on a software model, they design it on a hardware model, they will always be more expensive than we are by at least a factor of 2. And that's where we see it today. We are about 50% to as little as 25% the cost of equivalent gear from F5, as an example. But they have a huge R&D burden they have to carry. They have a huge marketing burden. They have a huge personnel burden. And all that cost gets shifted to you. With us, again, think Microsoft versus the old Sun Microsystems as far as pricing models go. That's kind of what you see with Kemp. And then always go with a multi-sourcing strategy. Don't single thread anything in your network. Don't pure fleet any one technology component. When you do, you're going to run the risk of that component failing and you having a big problem. So what are the 5 tips? Avoid vendor lock-in at all costs. Don't let this happen to you. Use operational requirements instead of technical requirements. Make easy use of critical parameter. Don't deny people the opportunity to change things in your network. Allow change, foster change, incentivize change. And then do total cost of ownership analysis on awards, because buy in low, get well through the support years has been used way too much by vendors, and you need to go ahead and kill that off so that you get the best value overall. So now we're into questions and answers, and I'm sorry I ran a little bit over on the presentation, but let me go ahead and pop into the question section here and begin to see what I can tell you. Okay, I have one here. Actually, I've got 4, I see. The one, I think I covered this, but we have 4 data centers and hundreds of applications. Kemp solve my load balancing needs, and that's kind of our bread and butter, right? Multiple data centers, multiple applications. We can do 1,000 applications per load balancer. We can do 1,000 backend servers as well per load balancer, and we can load balance, grow load balancing by clustering or by doing geo clusters. And there's really no realistic limit to how fast we can go. It's just the way the technology is designed is to be scalable. So yes, we have both global load balancing and application load balancing. We can cover multiple data centers, multiple applications. And but to really know more, we need you to get a hold of us offline, and we can then talk about the applications you're actually going to load balance. We do have the ability to do single sign-on, and for the government people out there who have a need to do certificate-based authentication, either with a CAC card or a PIV card or a SIPR token, we support those methods of authenticating to back-end web servers. We translate that to a technology Microsoft put in place years ago called actually it was MIT did it, and it's called Kerberos for authentication. It's token-based authentication. And we can support other strategies for authenticating the back-end web servers as well, and other types of servers. Next question, I cannot expand my current data center. So I'm looking to add capacity to existing applications using AWS or Azure. How can Kemp help me? The answer is pretty in my mind, is pretty straightforward. If you had stuff on-prem and you're now adding stuff to some other computing environment, cloud-based is more likely what you're going to do because of ease of being able to add things into the cloud. You now need to be able to direct users to where they're going to get the best application experience or use all that capacity, right? You don't want to have capacity you're abandoning because you're doing something in the cloud. So using our global load balancing services and our application load balancing services, and we can live both on-prem and in cloud. And we can even work with other vendors that have a different solution on-prem, and we can put us in cloud, and we can globally load balance across all of it. So the ability to scale out into the cloud, this multi-cloud and hybrid cloud is a real strong point for Kemp. We offer products in Azure and AWS that are pay-as-you-go. We also offer bring your own license models. So if you plan to be there for a while, and in most cases, when you look at a year to 18 months, and it's less expensive to bring a pay your own license than it is to do a pay-as-you-go license. But you can start with a monthly bill just immediately, and if you're putting stuff in if the other piece of the puzzle is you're bringing something new up in the cloud, you to protect that thing, you need to do what's called secure application publishing. It's a common term. What that means is the users connect to you, to something that acts as an app proxy and something that acts as an authentication proxy. So the users cannot connect straight to the back-end servers where the applications are hosted. So you protect the back-end servers and the data that's on them from rogue user attacks. And you still then, at the same time, you improve the user's experience by caching, compression, perhaps SSL offload. So yeah, the answer is if you're going into the cloud and you want to do a hybrid computing environment, we can definitely help you in that environment. I've got another one here that's talking about VDI, and that's kind of a hot topic right now. I've seen it all over the network. And I'm considering buying a VDI in a box solution to handling increasing demand for remote access. Is load balancing important? First, VDI in a box is a great idea. I mean, you can go to Dell or any other manufacturers, HP, the big boys out there, and you can say, I want you to integrate everything into a chassis, and I want you to send the chassis and maybe even a small rack and just power it up, and I'm up and running, and I got all this capacity, and I didn't have to do any of the integration myself before it showed up. So that's a great strategy. These in-the-box solutions right now especially, or in the cloud, are phenomenal strategies for growing capacity. And VDI in particular needs load balancing. If you look at the reference architecture for Citrix, or you look at the reference architecture for VMware, for Horizon, it shows you right in the documents that load balancing is required. Because we work virtual, in either Hyper-V or ESXi, KVM or Zen or Nutanix Acropolis, all those hypervisors we support, we can be the load balancer in the box, physically in the box, not adding extra hardware. We can be logically, software-based load balancing to meet the requirements these applications have for VDI. We do it very affordably. We're not going to be the major portion of the cost of the solution. So I've got another one here. I'm being directed to move all users to Office 365, but I still want them to have a seamless experience. I heard I can implement Active Directory Federated services and connect it to Office 365, and my users will not need to sign on a second time. Is load balancing relevant to make this work? So Office 365, or you hear Teams now, all these things out there that are running, you have to authenticate to them somehow, right? You have to sign on to them somehow. If you use just the cloud-based service, you're going to have to sign on a second time. But if you want to integrate your authentication services, your Active Directory environment, in the cloud, into the cloud service providers, there is an interface, and it is called Active Directory Federated Services. It's a SAML interface. You stand up in your data center or on your Active Directory domain controllers, turn these services on, and then you go ahead and you go to Azure or Office 365, and you integrate authentication, use integrated authentication with your on-prem instance, and you can then sign on once to your workstation. And when you click on an application that resides in Office 365, you are not prompted again to sign on. So the users get a seamless logon experience when they do that. To do that, you are delivering an application to Microsoft. The application you are delivering is called Active Directory Federated Services. And anytime you deliver an application, you need to load balance it and make sure that you can scale it across multiple nodes, and you can protect it from anybody trying to access it improperly. So yes, absolutely, we have workloads that are designed, optimized, templated for Active Directory Federated Services. You can stand us up. We can stand in front of those ADFS servers. We can ensure that they're load balanced properly. We can collect usage statistics and performance statistics off of them. So if Microsoft calls and says, hey, I can't, if you call and say, I've got problems with Office 365, Microsoft says your problems are authentication related, you can prove they are not, because you will have performance stats on your ADFS environment. What you're providing to Microsoft, you can prove is working the way it should be working. More importantly, by load balancing authentication, which is really important for any application, you can keep your performance levels up as high as you can possibly get them for your end users. So this is, let's see. Is the WAF application based on ModSec and OWASP rule sets? The answer is yes, which means you can write your own rules if you want to. You can consume the community rules. We actually have a subscription service we work with TrustWave on that will provide new and emerging rules for the web application firewall service to deal with threats that you don't know of. The system is really oriented towards out of the box, being able to support blocking the top 10 attack vectors against websites. So if you've heard SQL injection, everybody here has heard SQL injection. It's just a couple of check boxes on the web application firewall, and you block that attack into your inbound systems. Let's see, that one done. That's all the questions I've got in the queue right now. If anybody else has a question they haven't entered yet, if you could go ahead and please type it in at this time. Otherwise, I think we're about done with the presentation. I might be able to give you back a little bit of your life, another 5 minutes. I don't see any more questions showing up. So thank you, Kemp. Thank you for taking time today to come out and listen to us and our discussion on best practices of top 5 tips, load balancing federal networks. Real fast recap. We're on the Doden APL. We're designed for easy use. We're there. We're here to help you. And if you remember one thing, just one thing only, it doesn't have to be hard and it doesn't have to be expensive. And if the vendors you're dealing with tell you it does, then you're dealing with the wrong manufacturers. There are solutions out there that are easy, that are affordable, and that have extremely high customer satisfaction ratings. 98% post-sales customer sat. Can't say anything better about a company than we care about our customers so much that we were able to achieve those kinds of numbers. So let me go check and see if there's anything else. Okay. So again, thank you so much for your time today. If you need to get a hold of us, kemptechnologies.com is a great place. We'll have some links available to you that point you to certain websites. We have a federal government web page. You can go ahead and either search government when you hit the web page, or go kemptechnologies.com/government. Or because we've kind of branded this thing called application experience, it's a term we use a lot. We actually have a domain name we use, kemp.ax. You can go to kemp.ax/government and get to our website. There's contact us information in there about how to reach both myself and Jim Justice, our sales lead for the federal government. And when you work with Kemp, you get more than just a product. You get a company whose goal is to make you successful in why you bought the product. So we'll be working with you to make sure that the applications are working with the load balancer properly. We're not going to tell you, hey, that's somebody else's problem. Go talk to them to fix it. When you bring us an issue, our goal is to satisfy that issue, and you will be then one of our happy Kemp customers. So thank you so much, and we'll go ahead and watch out for new webinars coming from Kemp in the near future. Thank you. Bye.